So this is another question from IIT JEE PYQ. The question is from the chapter circular motion and it is from the year Advanced 2014. This is an important question. Here is the question. A wire which passes through the hole in a small bead is bent in the form of quarter of a circle. The wire is fixed vertically on the ground as shown in the figure. The bead is released from the top of the wire and it slides down the wire without the friction. Okay. As the bead moves from this point A to point B, the force it applies on the wire. Okay. That means we have to give the statements related to that the bead is applying some force and what is the direction of that force on the wire. Okay. So here let me draw this situation. This is the vertical wire frame. This is the point A and this is the point B. Okay. Let us suppose this is the intermediate situation here and it is the bead. Okay. And this is the radius R. Let me suppose this angle is theta here. Now if I draw the force is acting on this bead, then one will be a normal force acting in the radial direction, radial outward direction, that is N. Okay. So here I am taking this is the radial R positive direction, R cap, and this direction will be negative R cap direction. Okay. Let me call velocity of this bead at a point, at some point, intermediate point will be V. Okay. And one force will be acting in the downward direction, that is the weight of this bead, mg. If this angle theta, then this angle will also be equal to theta. Then the component of mg in this direction, radial direction, that will be mg cos theta. Right. Now if I write the equation of motion in the polar coordinates for this bead of mass m, then F radial will be equal to mass into A radial. Okay. What are the radial forces acting on this bead is that N is in the positive direction and this mg cos theta is in the negative direction. Mg cos theta, that is equal to m into the value of radial acceleration is what? Minus v square by r. Okay. So here the value I can write is mg cos theta minus normal, that will be equal to mv square by r. Okay. So this is our equation. Let me call it, this is the equation number 1. Now I will have to apply the conservation of energy at this stage. If I draw, this is the level which is having zero potential energy. So what is the potential energy at this point A? So initially at point A, the velocity of this bead was 0. And at this point, intermediate point, velocity we are taking V. Okay. And this length will be equal to what in this triangle? If I take the component of R along this, then this length will be equal to R into cos theta. And this length will be equal to upper small length R into 1 minus cos theta. Okay. So I can apply the conservation of energy here. I will directly write the equation. Sorry. Applying conservation of energy. So initially I will write the kinetic energy is what? 0. So kinetic energy plus potential energy initial, that will be equal to kinetic energy plus potential energy final. Okay. So initially kinetic energy is 0 and what is the value of potential energy at initial point? That is equal to mg h. H is what here? R into 1 minus cos theta. Okay. that will be equal to the value of kinetic energy here is what? Half mv square plus the value of potential energy at this point I am taking 0. This is our reference point. Okay, so here potential energy will be equal to 0. So from here I can find out the value of this v square by r. So v square by r will be equal to what? 2g r into 1 minus cos theta. Okay, so now from this equation number 1, if I substitute the value of this mv square by v square by r in this equation, then what will be this equation? We can write here, substituting this value in equation number 1. Okay, then the equation 1 will be mg cos theta minus normal, that will be equal to what? M into v square by r, and the value of v square by r is 2gr into 1 minus cos theta. Okay, so here this is the value of let me calculate the value of normal here. Normal will be equal to mg into cos theta minus m into 2mgr into 1 minus cos theta. Okay, so this is the value of normal. So let me make you understand the situation here, how this bead will be doing motion in this frame. So this is the wire frame actually, and this is our point A and this is our point B. Okay, so initially this bead is like in this situation. Okay, so initially it is applying some applying some force on this wire, like in this direction, that is mg. Okay, and it is moving in this direction. The upper end of this bead is contacting with the wire frame. There will be some intermediate situation where this normal force will become 0, and there will not be any type of contact between this wire and this bead. And after that there will be a situation when this inner side of this bead is in contact with this wire frame. Okay, so let me calculate at some angle theta the normal force between this bead and this wire frame is 0. So what will be the value of this angle theta is? So normal force becomes 0, that means mg, let me take it common, into cos theta minus mg here, wait, I think we are missing something. Here r will not be there, so this r will not be there here, so r will not be there. The value of v square by r we are writing, that is 2g into 1 minus cos theta, so this r will not be there. So normal equal to 0 means mg into cos theta minus 2 into 1 minus cos theta. Okay, this term will be equal to 0. That means cos theta minus 2 plus 2 cos theta, that is equal to 0. So clearly we can see that cos theta will be equal to 2 by 3. Okay, so this is the situation where this normal contact between this bead and this this wire frame is 0. Okay, so at theta is equal to cos inverse 2 by 3, the normal force between this bead and wire is 0. Okay, and from this normal equation we can we will be substituting some equations here. Let me call it normal equation is equal to what? Mg cos theta minus 2mg into 1 minus cos theta, 2mg into 1 minus cos theta. Okay, let me simplify it more. Then I can write mg, I will take it common, and mg 3 cos theta minus 2. Okay, so this will be the equation for this normal, right? So here I can clearly say that if our cos theta is, greater than 2 by 3, then the value of what? Then the value of normal will be greater than 0. That means it will be in positive direction, positive radial direction, plus r cap, radial direction. Okay, and if this cos theta is less than 2 by 3, then the value of normal is less than 0. That means what? It will be in negative radial direction, right? So negative radial direction means what? As I have told you earlier, that this is our positive r cap direction and this is our negative r cap direction. So if cos theta is greater than 2 by 3, then normal will be greater than 0. Okay, that means normal is acting on this bead in the positive direction. That means bead is applying some force in, so I will write with the red pen here for the first case. If cos theta is greater than 2 by 3, that means bead is applying force on wire in inward direction. Okay, so that normal force on the bead is in outward direction. Similarly, for cos theta less than 2 by 3, the bead is applying the force on the wire in the outward direction, so that the normal on the bead is in inward direction, that means negative r cap direction. So which option for this question will be correct? For this particular angle theta, that cos theta is equal to 2 by 3, the bead is applying force in inward direction, then after it will be in outward direction, and at this point the force will be 0, since normal will be 0. Okay, so the option D is correct. Radially inwards initially and then after radially outwards. Okay, so this option D will be correct here.